bases, and indicators. In this topic, we will discuss how different substances can be classified as acids and bases. One way of classifying elements in chemistry is by finding out whether they are basic or acidic. Acids are found in many naturally occurring materials which are used in everyday life. Some occur in the foods we eat, such as lemons and other citrus fruits, vinegar, and some soft drinks. In the laboratory, there are various acids which are used, which include sulfuric and hydrochloric acid. These are referred to as mineral acids. Bases are substances that react with acids to give a salt and water.
Colored flowers can be crushed, ethanol or propane added, and the mixture filtered to obtain the solution. This solution can be used to test whether a solution is an acid or a base. The flower extracts can be used to test different solutions, such as distilled water, dilute sulfuric acid, dilute hydrochloric acid, ethanoic acid, sodium hydroxide, and ammonia solution. The color of the flower extract in these solutions is recorded on a table.
From your observation, certain substances show the same color. Acidic solutions show red color. Basic solutions show blue, while neutral solutions show green color. The flower extract acts as an acid-base indicator. Therefore, an indicator is a substance that shows a definite color in acid or basic solution.
Flower extracts do not give consistent results. Commercial indicators are therefore used. Examples of commercial indicators include phenolphthalein, methyl orange, red litmus paper, blue litmus paper.
Blue and red litmus paper. Litmus solution. Phenolphthalein indicator.
Commercial indicators can thus be used to test whether a substance is acidic or basic. This can be done by adding different indicators in a solution of hydrochloric acid and in ammonia solution. 6 test tubes are labeled. Test tube 1, 2, and 3 contain hydrochloric acid, while test tubes 4, 5, and 6 contain ammonia solution. These indicators are only used to distinguish between acids and bases, but do not show the strength of the acids and bases. This can be shown using the universal indicator. The universal indicator shows a series of colors as the acidity or alkalinity changes. These colors are associated with numbers, which form the pH scale. Weak acids have a pH of 4 and 6. Strong acids have a pH of between 1 and 3. Weak bases have a pH between 8 and 11, while strong bases have pH values of 11 to 14.
A pH chart can be used to show both the color and pH of a substance. The chart below shows the pH colors of different substances.
The pH values of different acids and bases can be determined. Different solutions of water, dilute sulfuric acid, dilute hydrochloric acid, ethanoic acid, sodium hydroxide solution, ammonia solution, lime juice, antacid tablets, and sour milk are used and the pH indicator added.
Sulfuric acid turns red, hence a strong acid. Ethanoic acid turns yellow, indicating that it is a weak acid. Water turns to green, showing that it is neutral. Ammonia solution turns to blue, showing that it is a weak base, while sodium hydroxide solution turns to a deep blue solution, indicating that it is a strong base. We can therefore make the following conclusions. As the strength of an acid increases, the pH value decreases. As the strength of the base increases, the pH value increases.
Acids have a sharp taste, while bases have a bitter taste and a slippery feel between the fingers. Acids react with some metals, forming a salt and hydrogen gas. However, copper does not react with hydrochloric acid. The following equations show how metals react with hydrochloric acid. When dilute nitric acid is added to calcium carbonate or sodium hydrogen carbonate, and the test tube corked with a delivery tube immersed into another test tube containing lime water, a reaction takes place.
Acids react with carbonates and hydrogen carbonates, forming corresponding salts, water, and carbon 4 oxide gas. The carbon 4 oxide gas forms a white precipitate with lime water.
Acids react with metal oxides and metal hydroxides, forming metal salts and water as the only products. These equations show how they react. Acids have a sour taste. 10 blue litmus red react with metals producing hydrogen gas. They also react with carbonates and hydrocarbonates, forming salt, carbon 4 oxide and water. Metal oxides are bases and they react with acids, forming salt and water only.
Acids and bases have various uses in daily life. Some of the uses are illustrated in the pictures below. Hydrochloric acid is found in our stomach. It helps in digestion of food. Excess acid in the stomach causes stomach upsets. To remove excess acid, antacid tablets such as Eno, Actol or milk of magnesia, that is, magnesium hydroxide solution, are used. Baking powder is used in baking to raise the dough. Car battery contains sulfuric acid. Toothpaste contains a base which neutralizes the acid in the mouth. Air and combustion. In this topic, we will discuss what air is composed of and its properties.
Air is a mixture of different gases. The percentage of the active part of air can be determined using various methods. Copper turnings in a combustion connected to two syringes on either side are heated as air is passed from the syringes back and forward. Copper metal turns from red-brown to black. Copper metal uses part of the air during combustion. 20% by volume of air is used up. The reaction can be represented as follows.
From the results, 20% by volume of air is used up when the copper is heated. The 20% by volume of air used up is oxygen, hence oxygen is the active part of air. In this experiment, copper metal combines with oxygen to form copper 2 oxide, which is black in color.
When a well-lit candle is placed on a beehive shelf, on a water trough and covered with a glass jar which is graduated, the burning candle is extinguished and water rises up in the glass jar.
The candle lights for a while and then goes off. The level of the solution in the gas jar rises. Therefore, The solution in the gas jar rises to occupy the volume of air used up during combustion. The original volume of air in the graduated jar is recorded. The final volume of air in the graduation jar is also recorded. It is then possible to calculate the amount of air used up during the burning of a candle. The following are some sampled results obtained.
The original volume of air and the final volume of air are recorded. The percentage volume of the air used up is calculated.
20% by volume of air is used up when the candle burns. The part that supports combustion is the active part of air. The active part is oxygen, which forms about 20% of dry air by volume. The part that remains in the gas jar does not support combustion. This component of air is inactive and is mainly nitrogen.
The process of fractional distillation of liquid is as follows. Step 1. Air is purified by passing it through filters. Step 2. Carbon 4 oxide gas is removed by passing the air through concentrated sodium hydroxide solution. Step 3. The remaining air is condensed to about -25 degrees centigrade to remove water vapor which solidifies out as ice. Step 4. The air is compressed to about 200 atmospheres. The cooled compressed air is allowed to expand rapidly. This process is repeated until all the air liquefies. Step 5. The liquefied air is then passed into a fractioning column containing compartments. Each compartment is slightly at a higher temperature than the one above it. The components of the liquid air then separate according to the boiling point. Nitrogen distills off fast because it has a lower boiling point of -196 degrees centigrade, followed by argon at -186 degrees centigrade, and finally oxygen at -183 degrees centigrade. Liquid oxygen is transported in large insulated metal tanks.
Buildings are destroyed by rust. In this topic, we will discuss what causes rusting and how to prevent it.
By the end of the lesson, you should be able to 1. Carry out experiments to investigate the conditions necessary for rusting. 2. State the composition of rust. 3. State methods of preventing rusting.
Five boiling tubes, each containing 2 clean nails, are placed in a test tube rack. To the first one, tap water is added. To the second, boiled water followed by oil is added. To the third, cotton wool is placed halfway the test tube and calcium chloride is poured into the cotton wool. The fourth tube contains only the nails, and to the fifth, salt water is added to the nails. The nails are then left for a few days.
From the observations made, we can conclude that water and air, or oxygen, are necessary for the rusting of the nails. Rust contains mainly iron 3 oxide, which is hydrated.
Rusting destroys machinery, equipment and roofs made of iron. Prevention of rusting is therefore of great importance. The following methods are widely used to prevent rusting of iron. Painting is one method used to prevent rusting and slows down the process of rusting. Click to play the video to observe how painting takes place. Plastic coating is also used to prevent rusting. This is a process of coating a material with zinc. Coating iron with zinc slows down rusting because zinc is more reactive than iron. The zinc undergoes corrosion instead of the iron. Oiling and greasing is another method used to prevent rusting. This method is used for door hinges and moving parts of a machine. Click to play the video and observe how oiling and greasing takes place.
Oxygen is one of the components of air.
The reagents used to prepare oxygen gas in the laboratory include manganese 4 oxide and hydrogen peroxide. Click to play the video to observe these reagents. Manganese 4 oxide powder is placed in a flat-bottomed flask and hydrogen peroxide is added drop by drop using a dropping funnel. Play the video to observe how oxygen gas is prepared. Effervescence occurs while producing oxygen gas. Before the gas is collected, a few bubbles are allowed to escape. The gas jar is removed by covering its mouth with the gas jar lid while still underwater. The products formed when manganese 4 oxide reacts with hydrogen peroxide are water and oxygen gas.
Oxygen gas can be dried in the laboratory by passing it through concentrated sulfuric acid.
Concentrated sulfuric acid is referred to as drying agent. A drying agent is a substance that removes water from another substance.
Oxygen gas can also be dried using anhydrous calcium chloride. Oxygen gas has various properties. When a glowing splint is put into a gas jar containing oxygen gas, the glowing splint relights. When a red and blue litmus paper are put in a gas jar containing oxygen, there is no effect on the litmus paper.
Sulfur burns in oxygen gas. Note that oxides of sulfur and phosphorus are poisonous, and so the experiment is carried out in a fume chamber. Click to play the video to observe what happens when sulfur is burned in oxygen gas.